for example, medical images, you can do biometric recognition for a chest X-ray or...
So it won't be solved organically. It's something that we have to act on it.
Yes.
Because just by chance, if 90% comes from one population, you have vastly more data from that population than the other. Hey guys, welcome to another episode of the NILG.AI podcast. Today we have Naser Damer with us. He's a senior researcher at Fraunhofer IGD from Germany, an international leading institution for applied research in visual computing. Thank you, Naser, for being here.
Thank you, Kelvin, for having me.
Perfect. Amazing. So I checked your Google Scholar, right? And you have published almost 200 papers. So it's like you haven't rested for a while on that work. And over 130 or something were included faces directly on the title. So why faces? Why did you choose faces?
I work in biometrics. This is my field. There can be more than faces. However, faces as a problem, face recognition and related problems in face recognition is a problem on the edge of computer vision. So there are few problems in computer vision. If you go to major conferences and so on, you see that the innovations on these problems, and then they are copied into other problems. The solutions are copied into other problems. And faces within biometrics is the leading on the edge problem. It is also challenging because in a computer vision problem, you want to say, I want to differentiate between a cow and a tree and so on. And I know these classes, but in face recognition, you want to differentiate between Naser and Kelvin. But you don't know the class of Kelvin and Naser, so you need to learn how to map different identities. So it's a little bit added challenge.
Okay. Besides face, what do you have? You have fingerprints?
Fingerprints, iris, these are the major used.
Okay. Nowadays you have even gaze,
everything, yes. Even signals from the brain, signals from the heart and so on. These are things, but they have much more limited use cases, I would say.
Okay. And we relate less with those signals as humans that we face than with faces.
So,
right?
Another reason why face is used widely is that we accept it. It's seen okay to know you from your face, so you see your face as a less private measure.
Yeah, exactly. So even though our face is our most recognizable attribute, we don't perceive our face as being something private.
Yeah, we can talk about the privacy issues of faces. I don't think that the face itself is the privacy, it's the possibility of processing so many faces is the privacy issue.
Yeah, and we will get into that. So we talk about faces, fingerprints, gaze, I don't know, brain activity, and all of these fall into biometrics, okay? Yeah. And when people think about biometrics, it's just to open doors and to get access to. But what is biometrics? If I am, assuming I'm 10 years old.
Yes, it is as simple as your mother recognizing you in your school picture. So it is just to have two samples of one person, samples that this person are. It's not something that you own or something that you know, like a password. It is something that who you are, and you can look at it twice and say that these two times I looked at it, it's from the same person. Okay. It's the two pictures of you that your mother can say, yes, this is the same person, he's my son.
Okay. So it's basically matching two, I won't say two identities, but two observations of yourself.
Exactly.
And this could be a face, two faces of you. This could be two fingerprints.
This could be how you knock on the door.
Okay.
Yeah. So
it could be how you knock on the door. That's nice. And then we have, what are the major problems in biometrics? So we have, for example, I know we have like recognition, and I don't remember the other name. Like it's when you want to know if two images are from the same person, and then when you want to know like who is this person without the reference.
Yes. So this is let's say when it comes to really finding the identity in biometrics, these are the two use cases: is to make sure that two samples are from the same identities or to find who is this identity belong to. But in the back end, they are the same problem. So it is just doing the verification to check if two identities are the same many times. However, there is so many, there is the major problem is to make this process accurate despite variations, despite age difference between the two samples, despite pose differences, occlusions, and so on. So all these issues are related to how accurate is this process, but there are too many issues to make this process secure. So for example, if you're using it to log into your phone, it will make sure that it's actually you and not a picture of you that is presented in front of the phone. So there are side issues beyond accuracy.
Okay. And so we have the fact that the signal changes over time, and maybe we feel that the face doesn't change, but it changes a lot. Mm-hmm. Like locally, if I change my haircut, right, it will produce a change, but over time we get older.
Yes.
Is that an open problem in biometrics?
I would say it is a problem that can be solved better.
Okay.
So face recognition still works, but works much less accurate. So it is this aging problem is a problem, and it's mainly because it is like us. It's like human. It's like any other AI. It needs to learn from data. Okay. This is one side. The other side is you actually look a little bit different between 10 years old and 50 years old. You know. Yeah. So you really don't look the same. So it is a problem for humans also.
Of course. Yeah. Is there any signal that, for example, a fingerprint? Is a fingerprint a more stable representation?
More stable. Relatively more stable.
Okay.
It has other problems. Fingerprints are having more problems with, like, if you work something with your hands and you affect your hands and so on.
Of course.
But usually biometrics, like fingerprints, is stable. Above 8 years old, above 12 years old. There's different studies that will.
Yes, for kids we have a lot of variations, but
after some time, it's relatively more stable.
Okay. Of course, when we envision biometrics, we can unlock our phones with our faces. We can have automated gates control on passports. Is there? And then of course we always go into CSI stuff like discovering a criminal from their face. Is there any other non-obvious application besides this?
There are applications that are now emerging. The applications of biometrics that we see now that were not there 5 years ago, for example, automatic border control was much less available a few years ago. The phones, if you think about it, it's really only like maximum 10 years ago that this started.
But it's always about getting access to something.
It's always about getting access, and that this technology is developed enough for this use case. So in border control, you have perfect illumination, you have the use case is simpler, and by the time that these start to develop, face recognition algorithms, let's say, are fast enough to do this in a good time. Okay. So you don't have to wait 2 minutes in front of the gate. It will take 10 seconds or 5 seconds.
Okay. To compare you against millions of.
No, actually, in the border control, you compare you to the picture saved on your passport.
Okay.
In most cases, there are countries that they have a database, but even then, they compare you to the picture of you last time.
Okay. Or you against the 5-10 criminals they have to check.
Yes, and against blacklist sometimes.
Okay.
That happens also. But it depends on which country, what do they do. In the EU, usually it's you against the picture stored on your passport.
Okay.
Yeah. But there is so much chance for new applications that are still limited by what biometrics can do. For example, now new applications are in automotive domain. In the cars, they want to make sure that the driver of the truck is the driver of the truck for responsibility reasons, and also related its biometrics as well to make sure that the driver is not drowsy and so on.
Okay.
From the face image. For example, the illuminations in the automotive domain is not so good, so you need algorithms that will do for that. Big part is that in so many applications, including border control in faraway land border places, you don't really have the hardware to do it. Like it's a big deal to have big hardware in a car, it's so much cost, and therefore a big direction is to go towards efficient machine learning, smaller models, things that can open the use cases that we are not using now.
Okay, and do not require connectivity, and they can be on the edge device.
Yeah.
So on an ideal world, if we reach 100% accuracy on biometrics, I know it's super tricky, but let's assume we reach 100%
We're almost there,
accuracy.
like, in some use cases.
Exactly. And we get full access to these models everywhere without connectivity. We wouldn't even need passwords or even keys to turn on our cars. Right?
It is the ideal case. Some would argue that this is not so safe. Maybe there is attacks against biometric systems, but there is attacks against other issues.
What would be attack? Like getting a mask or having a printout of my face?
Having printout or getting a mask or overriding the signal or a conventional IT securities, like attacks on the transmission itself. But you cannot say that this is it's a trade-off. I would say security and usability is a trade-off. Biometrics will give very high usability in many cases. And as long as we're taking the security higher, it will be much better than having a token and a password. For example, where I work, I have to have a password that have 16 characters, including numbers and 16. And special characters, and so I always enter it 3-4 times wrong.
And you have to rotate it every 6 months.
I have it written somewhere. That's totally not secure. Okay,
this will be removed from the podcast.
It's fine. It's just
it's part of it.
It's part of the thing. And it is one of these stupid passwords also. Like the easy to guess ones, because I have to have 16 characters.
Of course.
In the case of a normal user like me, I think if they will let me use face recognition, it will be more secure.
Of course. So we already talked about the stability of the signal, which is basically, you change over time, and faces do not change that fast, but maybe hard conditions, may change, or depending on the signal we got. You also mentioned illumination as a challenge. What other challenges are there? I remember some work around the fact that face recognition algorithms do not work as well for Black people. Is that because we don't have data? Is it because contrast? What is the main aspect?
So this is a big issue in biometrics, in machine learning in general, but in biometrics we are dealing with humans directly, and therefore human demographics is something important. We need face recognition, but not only face recognition, the things around it. How well do we detect attack on your phone verification system with face recognition? This is also a thing, and so on. All these perform a little bit differently between demographic groups, between people with darker skin, lighter skin, different origins, between male and female, and you can go more with these categories.
But do you think it's more because we don't have enough data from some of these groups, or is it because there is something intrinsic on their faces?
We know that if we have enough data, this bias or difference in performance, because I don't like to use the word bias so much, because it would mean that this is an intentional thing, but it's just performance differences. Between different demographic groups. We know that if we have a more data, more representative data of everyone, these differences will be less. But I cannot tell you if it's not something intrinsic. Like it might be the case that people from ethnicity X, actually their faces looks more similar to each other than people from ethnicity Y. It might be the case. But our goal as developers of just such algorithms is to take this unfairness or difference in the performance to the minimum level, hopefully to zero.
Is it exclusive from RGB images, or if we take into consideration other stuff like depth images, will that get solved faster?
I think it will appear everywhere, even if we're taking depth images. I don't know for a fact.
Okay.
But I think this will be an issue, especially if it's based on less representation in the training data.
Yeah. And that, of course, as computer scientists, our goal is to minimize those issues. But if 90% of the population is from one ethnicity and 10% is from the other ethnicity, just by organic collection of the data, you will have 9 times more data than from one group than from the other group. So
yes, that's true, but we should look at that as each biometric process by itself. So each search, for example, if there is, as you said, 90% are from one group, 10% from the other group. If the police, for example, search in their criminal database if a certain person, suspect, is in this database or not, and this person was from the 10% group. This is one process. If the system is not fair, if there is difference in the performance, there is, for example, 10 times chance that this person, just because he belongs to this group, will be identified wrongly as a criminal.
Yeah.
So just because this person belonged to a certain group, they have 10 times chance to be identified wrongly as a criminal.
Because of the error rates of the models.
And when we look at this one chance, we can see that if we want to talk about ethical issues, like from a categorical imperative point of view, it's not okay. Exactly. Especially if it's something that is technically can be solved. This is my point. If we can solve it technically, we have to solve it technically.
Exactly. But we have to. So it won't be solved organically. It's something that we have to act on it.
Yes.
Because just by chance, if 90% comes from one population, you have vastly more data from that population than the other.
We have to do something. Yeah.
Exactly. So it has something that we have to put there in a guardrail that we have to put there in control.
But we are only putting there if it's necessary. We always have to think that these are problems that can be solved by our work, by research, by developing new products.
It's a technical problem.
But it's only doable if there is interest, financial interest.
Yeah.
You know what I mean?
Of course.
Yeah. And now lately there is drive for companies to prove that their algorithms are more fair.
Yeah.
And now that's why there is a drive behind finding solutions.
Yeah, of course. And the main issue there is that as long as you don't compromise the performance, and here I'm talking about regular applications like iPhones.
Yeah.
For example, if you want to unlock your iPhone, you want it to work equally good for everybody, or you want it to work super good for most of your clients. And then, what is the right incentive there as a company, right?
Yeah, exactly.
Yeah.
And if you are from the group that is treated unfair, from the 10% group, you are fine if it's unfair, but it's only 1% wrong, than if it's fair, but it's 10% wrong. Exactly. You know what I mean?
Yeah, of course.
Even from user perspective, accuracy, performance have to be up, but more fair.
Yeah, of course. Actually, and people may only be thinking here about race because it's the most well-spoken issue nowadays. But for example, with fingerprints, when I unlock my phone with fingerprints, so my hands sweat a lot, right? And that compromises the quality of the capture. And for me, it was a nightmare to unlock my phone using my fingerprint.
Yes.
And that is some sort of a lack of performance that is not necessarily race or whatever. It's just sweating.
Yes. It's also sometimes personal choices. If you grow a beard, face recognition will work a little bit worse. Yeah. Not necessary because your identity is not well represented. No. Probably because of data underrepresentation.
Of course. You started with face recognition, biometrics, And now you're getting more into explainability, explainable AI, right?
Yes.
Why explainable AI?
It's because of questions that you just asked me for. Why this? Why is face recognition biased or unfair?
Okay.
You know, so every question that starts with why, it needs explainability. We need to explain why certain decisions are made, why certain decisions were not made by AI systems. And I think it's a way to get it closer to the public, not necessarily the general public, but the user. That means the border guard that use face recognition to check the travelers. If this border guard gets a mismatch, but he sees that the person look the same as in the picture, the border guard wants to know why does the system give me a mismatch, you know? However, there's so much talk about explainability. We are still like, explainability is still a baby.
Yeah.
Like, it's so far away from real applications.
Yeah. It's far away from real applications.
I believe so. Like, it's getting there fast.
Yeah.
But even the categorization of what do you want to explain, how do you want to explain it, is not clear in the community, even in the research community.
Yeah, you know, I have a few stories around that. Multiple clients come to us and ask us to have explainable AI models. So they want the prediction or the decision, and then they want an explanation attached to it. For example, yes, this person has access, and this is to the gate, and this is why, or he doesn't have access, and this is why, or yes, this patient has cancer, and this is why, he doesn't have cancer, and this is why. And in most of the cases, of course, we generate the explanations that AI can generate now, which are very dumb. But even when we generate good explanations, what I have perceived is that sometimes they don't care about the explanation. They care about accountability. So who is going to be accountable for the mistakes? Yeah. For example, there is a criminal trying to get into a border, to pass a border, right? The AI model says this person doesn't look as the criminal, so you can let him go. And here's the explanation why. But the security guy recognizes the person. Let's say the AI model gives you an explanation of why it thinks it's not the same guy. Is that explanation enough for the security control guy to be safe against, a court in the future, for allowing a criminal to pass through the border? And whenever my clients ask us about explainable AI, the end result is like, it's not about the explanation. They don't care so much about the explanation as they care about potential risks on their so on their who is going to get fired if this decision goes wrong.
Yeah.
Okay. And that is at least a perception I had. And I also started working on explainable AI, but since the field is not there generating convincing enough explanations, the way we are tackling that, whenever a client asks us, I want explainable AI, we always say like, maybe we need to redefine the social contract or the agreements you have.
And also the explainable AI have different consumers. We as developers, we want explainability to understand what our model is doing and how we can make it better and so on.
Because you don't want to get fired for putting up a bad model in production?
No, because my model also wants to be better.
Exactly.
But I want to explain when I change this, what changes, how does it act differently. But this is not end user.
Exactly. This is a programmer. The
programmer wants to understand better what's going on.
To improve it, to correct mistakes. Maybe it's biased, so let's go for more data. Let's fix this issue.
Yes.
Okay. So that's one user. Let's say the data scientist, the programmer.
This is one. There is the user, the decision maker, that wants to be the system accountable and whatever.
Okay. This is the security guy.
I think the manager in the whatever AI using company.
Okay.
They want accountability.
Okay.
And there is the end user who's really looking at the decision. If it's a medical AI, probably it's a doctor that's seeing the output, and he wants to know, or she wants to know, why is this is the output of the AI model. Or if it's biometrics in the border control, it's the border guard who wants to know why the decision is like that. So we have this developer And I think we already have some tools that developers can get a feeling from.
Yeah.
You know, it's more of an art.
Yeah. But for developers, I think it's there.
It's
kind
there.
Yeah,
It's there.
Exactly.
But for decision makers and for real end users, it's not quite there.
Yeah, there is a special kind of decision makers. And here, of course, we need to talk about whether we want explanations for each individual case or for how the model performs as a whole, right?
Mm-hmm.
Because one thing is, give me an explanation of why this user was rejected access or why this patient has cancer. There is another use case, which is how does this model is making decisions,
Yes.
right?
Why is this model biased?
Exactly. And that the end user of that explanation is more of the regulatory organization, the regulatory process, right?
Yes.
Like the FDA wants to know how the model reacts.
Yeah.
So maybe that's a different also kind of user, because they are a decision maker on whether or not they will put a stamp saying this model is okay for to go to the market. And then there's another, I was here trying to map the users as you were speaking. I think there is another user, which is, let's say, not the end user, the security guy on the door or whatever, but the person that gets affected by the decision. For example, the patient, the person that do not get access to the gate or to the country, and there is something in GDPR which is recital 71, I think, which is we call it like the right of explanation, which is whenever there is an automated decision made on you, you should be able, you have the right to ask for an explanation. For example, you request a loan to buy a house, and the loan gets rejected, or the mortgage gets rejected, whatever. Why was the loan rejected? You have that right for an explanation if there was an AI, an automated process involved. My question is, we have that law, we have that recital on GDPR, but we don't have the technology to do that properly.
We don't have the technology, and the GDPR, as far as I remember, does not have clear explanation of what is this explanation.
Exactly.
You know what?
Yeah. There is no consensus.
You have to get explanation of what. Okay, what is the form of this explanation? Yeah. There are things in GDPR also related to biometric data, the privacy of biometric data, that is completely unclear what they are. You know? Okay. And this is what is explanation?
Yeah. For me, I mean, overall, I think I like GDPR. I will say I'm in favor of GDPR, but this recital 71 of the right of an explanation, I think it's 71. Yeah, but let's look for it. But I think it's 71. For me, it's just like saying, "Hi, we are covering this." You know, like we have this cover. European citizens, you are safe. But there is no definition of what is an explanation. So if you say, because the model says so, is that an explanation? Yeah. Or if you showcase the features that were used to decide why you don't have access to a credit or why you have a low credit score, is that an explanation? Is a heat map on an image, like, you have cancer because this part of the image is sensitive and
is red.
Exactly, because of this part is red. Yeah. Then you don't have approval for the treatment, or you should go through this treatment. Is that an explanation, yes or no? So since, I mean, and we are talking here about AI, but I mean, what is an actual good explanation? That is why not all kids perform well in school, right? Because one explanation applies to one and not to the other. So it's actually very tricky in that regard. Now we have, beyond GDPR, we have the AI Act, right? Mm-hmm. And it has some hard rules around biometrics. I don't know.
Yes, around more of the surveillance scenario biometrics.
Surveillance. Yeah. Okay. Do you think that will reduce investment on biometrics in Europe or not?
I don't think so, because the surveillance scenario is more from have a government users. So critical infrastructure might be surveilled in some countries, things like this.
Like highways, airports, etc.
Forensic works use biometrics, and in AI Act, as far as I understood it, this is still fine. And for non-surveillance scenarios, like using my face recognition on my phone or to enter the company, or, this is still fine also.
Because you are not tracking the user all
Yes,
the
yes,
ways just to
yes.
provide access. Okay, so let's say authentication on physical spaces, devices is fine. Surveillance of critical infrastructure is fine.
Yes. Logging into your bank account, authorizing a payment,
Okay.
all these things that we use.
So what is
1, 2,
forbidden?
3, 4 passports, PIN numbers, passwords are fine.
Okay, so what is forbidden in that case?
I am not the lawyer,
Okay.
but as far as I understood, there is so many limitations on live surveillance. So really having cameras in the streets that have technologies to identify people.
Okay. Both from government and from private, or only from private?
I read not the later approved AI Act, the draft before, and there was some exception for
government.
government.
Yeah.
Yes.
It's like, hey guys, this is wrong. People shouldn't be tracked unless we are the government.
That's actually a cultural thing. Like
Yeah.
in the US, it's the other way around. People are afraid of what government would do,
Exactly.
and they are fine with what Google would do.
Exactly.
And in Europe, people
We are
are
the
afraid
opposite.
of what Google, and they
Yeah.
trust the government.
Yeah, it's always a matter of trust.
Yeah,
when we come,
it's a trust.
when we come into this. So, the world changed in 2023. Again, the world is always changing, but there was a big change
Yeah.
in 2023 with the boost of generative AI. It's not like generative stuff didn't exist before, because we got GANs and we got a lot of models, but it got like surprisingly better in the last 2-3 years. In the last year, especially around the generation of synthetic data. Now you are working on synthetic data with biometrics. What are you doing around that?
We are already for 2-3 years working on synthetic data. There is so much synthetic data. Generative AI is seen in so many cases as a villain, I would say, like is something bad. But it's a technology that exists and we can use it a lot for good things. What we are doing now, you can, for example, in biometrics, generate really, really realistic faces. You wouldn't say if it's a real face or if it's generated
All
face.
hands have 6 fingers, but all faces are actually very good.
Yes, yes. Yes. What we are trying to do, we can use generated data for training of different parts of face recognition solutions. We can use generated data to evaluate face recognition, because this is also an issue. It's a real use case. We can use it as an attack if we are bad guys, deep fakes, and so on, and we can use it also to induce privacy. Maybe you want your picture on Instagram to stay there, you want to post things, but you want to change little things through generative AI. So you regenerate your picture so that it's not identifiable as you, but still looks like you for the normal user.
Okay, can you make me Skinner?
No.
Yeah, that's our issue, right? Yeah. So let's work hard on that application. I also need it.
Yeah.
Okay, good.
But generating data for training and evaluation is the most challenging part, because you need to generate consistent identity. You need synthetic identities, and you need variation of these identities. So you need your face, but your face in different poses, in different illuminations, and realistic variations, not variation that I would say, I want a different pose, I want a different illumination. No, give me variations that really exist in reality, but maintain the identity.
Okay.
And I can use this data that does not belong to real people, and therefore there is no ethical, legal, privacy issues. I can share it with others. I can develop solutions based on it. I can make these solutions better in terms of having so much data, in terms of being more representative of everyone. Like
the problem with the 90% versus 10% population demographic.
Exactly.
Okay.
Then I can make them 50-50 because I generate the data.
Of course, as long as the quality of the generation is the same for all demographics.
Yes. Yes. This is like second degree bias. Okay. But everything can be worked on. Exactly. It's definitely technically There's so many people motivate synthetic data by ethical use of data, by privacy compliance. This is fine. But the major thing, it solves technical problem. It solves problems with unavailability of data, of lack of variations, all these things. It will open up new applications. It's not only ethical and privacy and so on. It is solving a technical problem.
Actually, we got a project last year. When we proposed the project, we proposed to scrape data from. It was basically to recognize damages for customer support requests. And when we wrote the proposal for the project, we said, well, let's scrape data from damages, etc., then train the models, and that's it. The project got approved, but then the legal team from the company said, we don't want to use scrape data, even if it is not copyrighted or whatever. We don't want to use scrape data. Thanks God, we got at the same time the hype of generative AI and the growth of generative AI. So we generated synthetic data to train the models. Right, so it was this issue of not necessarily just the privacy concern, but also the availability. So at that point, the project was almost dead because we didn't have data.
Yeah.
Right. So thanks to the synthetic data generation, we were able to generate data, and it has the two sides of the coin. So we were able to generate data that we didn't have access to, and we kept customer data private. Mm-hmm. Okay. Mm-hmm. So we could train the internal models to recognize damages, and it was based on images and emails. So what happens if a customer submits a complaint about a car, let's say, with a damage, and has also an email where it has the address, whatever, and you don't want to train with that type of data. So we generated that data synthetically, and then we train a model on top of that. So the model never saw real user data. And for me, it has the advantage of the ethical concerns with privacy, etc. It has the advantage of not having data, which is one of the main blockers for people to not get into AI. It's like an egg and a chicken situation. I want the AI, but I don't have the data, and I won't have the data until I have use for it, because you cannot just start collecting data out of nowhere, and people won't give it just for the sake of giving it. They want something in return, and that something sometimes is like an experience that AI can provide, or an access that So this kind of synthetic data, for me, kind of solve this chicken and egg situation between data and training. Models.
Not always no data, but it's not good enough data.
Exactly. What are the main challenges around using synthetic data versus real data?
I think it's to really map reality. So images might look real, but the differences. So you want to train something on it or evaluate something on it, and you need the differences between different classes to be always representative of reality, and how to induce this with as little as possible reliance on authentic data is maybe the main challenge.
Okay.
So we are already, the images look good, what I mean? They look realistic.
They visually look realistic. Yes. Maybe the noise level is not there, and that causes difference on the model.
And inter and intra-user, inter and intra-class variability in the data. This is an issue.
Okay, so
how tight do you sample classes? How widely do you sample classes?
Okay, so in that case is how close to my face are those images?
If we talk about faces, it's exactly that. It's can I generate multiple images of the same identity, synthetic identity, that have the variation, for example, of age, of pose, of illumination, but still maintains the identity.
Okay.
That's if I have your picture under different illumination, in different ages, in different poses, I know it's you. But I need to put something around the generation process that maintains the identity and also give me very high variation. And still, you would look different than me in a degree that is also like the same degree that humans are different from each other. So classes are wide enough as reality, but classes also are far away from each other enough and not more than reality, you know?
Yeah.
Whether it's faces, whether it's X-rays, it's the same problem.
Exactly. You don't destroy the information in the image at the point that it belongs to their class. So a cancer patient is not a non-cancer patient, but still has enough variability.
Yes, exactly.
There. Okay, so maybe we could solve the problem of unstable signals with synthetic data. Because if biometrics, if the whole thing in biometrics is comparing your current version of your signal, your face, whatever, with the reference that you have, right? Now, and let's say this reference was on a dark place and this one on a light place, now I can manipulate my reference and make it closer to the style of my current.
You can do this, and you can actually, when you train your model, you have this variation in the data.
Okay.
Then it's already solved within the model.
Okay.
You know.
Okay, so in both scenarios, training and usage, you could even ask to generate an older version of my face, so I increase the quality of face recognition over time.
Yes. Actually, we did something once cool in this direction. It was a use case where there is very low quality thermal images of the face. It was used for night vision or something. And we generated visibly looking faces from the thermal images and then compared it to the reference that is visible, you know.
Did it work?
Actually works, yeah.
Did it work? Nice.
Yeah. You cannot add information, so the thermal image is very low resolution and so on, so it doesn't have so much information. But it does work because the very good working model of face recognition is used to visible information. Why? Because the data that it was trained on and it's available for so many people is visible.
Of course.
You know? So you take your thermal image to the domain where you have a model that works well.
Okay. Okay, makes sense. Nice. I have never thought about that. It's a very nice application. So I think we cover more or less everything around biometrics, right? So why biometrics, faces? Is there any other, let's say, signal that you see growing in the biometrics domain besides faces and fingerprints?
There is use cases that might be growing. For example, visible fingerprints. We need to understand that iris and fingerprint is well established.
Iris, yes.
Iris and fingerprints are well established technologies for certain use cases, for cases that are well captured when you do your ID card, when you check the border. Iris and fingerprints are well established. They have traditional algorithms. It's working well. But it's not easy to convince end users that instead of just walking towards your car door and will identify your face and you open it, you have to look into some iris scanner and, you know, it's a little bit creepy.
Unless,
for me to, you know,
unless you give them money.
You
read the thing about the war coin that was collecting.
I know. Did they? No, they stopped it in Spain, I think.
They stopped it in Spain, and here in Portugal they are deciding if they are keeping it or not. But yeah, people is scared of opening their car with an iris. But if you give them 50 euros, I think it's even less than 50 euros. They all go there to the shopping malls and go into a queue just to scan their iris. Yeah. But I don't know actually anything about that company. I only heard the news that they were forbidding it. But yeah, so we have iris. What other? So let's say biosignals like brain, etc. What applications will they support? Because for me, it's crazy like putting something on the brain just to track you and measure your performance. Why would you want to do that?
For me too, it's a little bit not application for wide usage. You know, there are some applications. For example, in let's say medical images, you can do biometric recognition for a chest X-ray or brain signals. And there is a use case, but it's a very niche use case, which is mismatches in the medical domain. That means that when in the hospital, they take X-ray today, and after 1 month, after 2 months, because of some medical case, it might be the case that they misplace one of the X-rays in the folder of another patient. And this actually happens. There are studies, and this is an issue, you know. Usually they have the name on it, but also there is a movement not to have the name on these signals or images, because it's a privacy issue if somebody attacked these databases and so on, so they can link it to identity. And it's a way to make sure that your records are clean, or every folder, let's say, of patients have only the x-rays of this patient. We make sure that all these x-rays of whatever the chest are from the same person.
Okay.
So there are use cases of the technology, but
they're
it's very limited,
very
like
vertical. And,
yes.
I have seen, actually, I worked some time ago, I won't say it's biometrics because it's not bio, but recognizing authorship based on the text. You have to text, is this a plagiarism of this other author, or is it the same person or not? I think that could be also another application. And then there was something we worked some time ago as well, which was based on typing patterns.
This is a very nice add-on to a login scenario, and actually used. It is implemented. There's so many providers that include these things. There is so much research about it.
And it's basically to prevent another person from typing your password. Your password and getting into
yes, Yes. It doesn't work as good as fingerprint or face, but this is understandable. It's not 99.999% correct, It can be 90% correct. That will still prevent 9 out of 10 attacks on your login scenario,
Exactly.
which is perfect.
Exactly. And if it forces you to put the password 2-3 times, that's okay, because in the end you will reduce, if you are the actual person, you will reduce the error rate.
Yes.
If you are not the right person, then that 90%
yes.
Won't easily get you.
So it doesn't always have to be so accurate to have
useful.
An added value.
Exactly. How do you see the future of passwords versus biometrics? Because now we use more passwords. So biometrics is growing, but now, for example, if we go into blockchain applications, like everybody says, I lost my key and now I don't have my Bitcoins, for example. Yes. That's an issue, right? So we are still rely heavily on passwords for many applications.
I don't think passwords will go away. And I think biometrics will grow more in this domain, but it's all about the use cases. So there will be use cases where you have to have a password and biometrics, if you want it to be extra secure. And there will be cases where you want security that biometrics provide, but also the usability that biometrics provide. For example, it's a use case and it's either personal preference. You can unlock your phone with your looking at it. You can enter a PIN. I choose to use my face because it's more usable,
more practical,
and it's not necessarily less secure.
I have a use case at home of why I don't want to use my face to unlock my phone, because my 3-year-old kid discovered that he can point my phone towards my face and it got unlocked. So I want to remove that just to make it a password. He still doesn't master numbers. So maybe I will switch back to passwords.
We can, if Apple don't have it, we can now do a patent that says the algorithm should know that you're holding your phone, not somebody else.
A new biometric application, right? Because of the stability, stability of your hand or something.
For sure, it can know if you're holding it or somebody else as well.
Yeah, I like that application. So, Naser, just to wrap up here, 3 book recommendations for the audience.
I'm not so big fan of...
it can be podcasts, for example, or...
for me, technical books, even when I was doing my bachelor and so on, it's not... I'm not very big fan of technical books, because there is a reason. It will go so much into details. And when you go so much into details, you miss the big picture. I would like to have the big picture and go into details where I want. Details are important, but you cannot limit yourself within details.
You're a Twitter user?
No.
Okay. No. Because Twitter is like the opposite way of getting into details, right? You have 140 characters or no?
Not so much social media stuff. Like I have Instagram, but like I have 30 followers. So as my sister, my mother. You know what I mean?
Okay. Now you will have 31. I will follow.
Yeah.
I'll follow. Don't feel bad. Well, in that case, thank you, Naser, for accepting this invitation of being here, for being here in Porto. I hope you are enjoying your stay.
Thank you for having me.
Thank you.
And Porto is great. Everyone should come.
Yeah, for sure.
For Porto people, they would say it's better than Lechbond. So
Yeah, exactly. And thank you all for watching or listening to this episode. Looking forward to have you on the next episode. See you soon. Bye-bye.